Welcome student to my channel Educare Maths and Science. Today also discuss the continuation of the organic chemistry. Under this organic chemistry, the isomers, the different. This is for the I.C.S.E, C.B.S.E and West Bengal Board class 10. Okay. So already the different types of isomer and the first one. This is the chain isomer is already discussed. Now today discuss the positional isomer, functional isomerism and metamerism. You know already what is isomer. Isomer means the same molecular formula but different their structure. Due to the isomer, the huge amount of the organic compound is formed. Huge millions of organic compound is formed due to the isomer. This the structure is very important. You know already in case of the organic chemistry. This is the very much different between the inorganic chemistry. Inorganic chemistry, there is no isomerization. There is no need for the structure. But in case of the organic chemistry or fiber, just carbon is the main and the hydrogen, oxygen and 4 or 5 elements are there. But they are different in arrangement due to the catenation property of the carbon compound. So this is a huge amount of isomer is formed. Isomer means first one, the main is the same molecular formula. In case of the sulfuric acid, H2SO4, you know, there is no other formula. H2SO4 means sulfuric acid. But in case of the organic chemistry, if you know the molecular formula, suppose here is C4H6. It's not identified what is the exact compound if you don't know the structure. So different structure is there. Due to the different structure, the different compound is formed, and that we actually call the isomer. Isomer means mainly the same molecular formula but different their structure, different compound is formed. Now here there is a position isomerism. In case of the butene, suppose C4H6. Suppose C4H6. That means actually, okay, C4H6 actually means, suppose if the structure is this, suppose here C4H6 butene. Butene means you know the triple bond. Suppose here is CH3. Suppose you just draw this is the triple bond is here. Triple bond is the position isomerism. What is the position of the this is the triple bond. If this is the position, this call actually, now this is the one position, this is the two position, this is the three position, this is the first position, because you know these are a lower condition. In case of the double bond, in case of the triple bond, if you just lower R, in case of the IPC naming, the lower R thing, lower R. So if you start from here 1 2 3, not that, if you start from here 1 2, so for that this is the one position, 1 2 3 4, so naming is but1ine. If this one is changed from here to here, if this one is changed from here to here, in that position, so this is this position, so this is actually the triple bond is the second position, so you write but2ine. This is the difference. This actually called the position. This, for that reason, the two other compound is formed, that is called the position isomerism. The position of the triple bond, where position of the triple bond is the first, here is the position of the triple bond is second. This is not occur in case of the inorganic compound. This is very much basic difference between the inorganic compound and the organic compound. So much isomer is formed, millions of compound is formed for that reason, because same molecular formula C4H6, but the position is different on the bonding. The triple bond, the position is different. Okay, so this is called the position isomerism. Due to the position, here is the first position, here is the second position. Is clear to you? This is the thing. Now here other one position isomerism. Here is this. Actually the formula is C5H10. Actually CnH2, the double bond, because of CnH2n, the double bond. Here is the triple bond, here is the double bond. The bonding position is different. Pentene 1, paint 1, paint 3 1. What is the actual structure? The double bond is here. Here is ketone. The double bond. Here is this. Here is this. So this is C5. 1 2 3 1 2 3 4 5. Here is 1 2 3 4 5. And hydrogen is O. O is there. Suppose this is 3 to 5, 3 8 to 10. Here is 3 to 3, 3, 6 to 10. This is. Okay, the position, these are actually 1. 1 means ketone. This also. The double bond. The position of the double bond for that reason is ketone is applied. Position. Here is 1, 2, third position. Here is 2, second position. So for that reason 1, 2, 3, 4, 5. But what is the position? This is pentan 3, 1. 3, 1 because the position is this. Here is pentan 2, 1 because the ketone is this. The double bond is there. The positional isomerism, that means the double bond here is the second position. Double bond is the third position. This actually the positional isomerism. Functional, under the functional isomerism this also there, but the position here is the particular the position. The double bond is where? Double bond is the third position, double bond is the second position. So this the pentan 2, 1, 1, 2 because the lower 1, 2 pentan means 1, 2, 3, 4, 5. The origin is pentan. Pentan, what is the position of the double bond? 2 position. 1, 2. The pentan 2, 1. Here is the what is the position of the double bond? Third position. 1, 2, 3. So pentan 3, 1. So 2 isomer is formed. Is okay. So this is the way. Okay. Now the second one is the functional isomerism. That means functional isomerism means the functional group, the different functional group. The main molecular formula is C2H6O. This is the main molecular formula, but you cannot identify which compound in case of the organic compound. I just repeatedly say you what is the difference between the inorganic and organic. H2SO4, that is always sulfuric acid. Always H2SO4 sulfuric acid. But C2H6O, this is dimethyl ether or ethanol. You cannot identify if you don't know the structure and what is the position. If you don't know the structure. Here is CH3, CH2H. Suppose this, the position. This is the functional group. Here is OH. This is hydrogen, this is hydrogen, this is hydrogen, hydrogen. Carbon always 4 hand is completed. You just always check carbon 1, 2, 3, 4, single bond. This is the carbon 1 hand, 2 hand, 3 hand, 4 hand. But the functional group is OH. Your total is C2. This total is, here is C2, here is C2, hydrogen 1, 2, 3, 4, 5, 6, 6. Oh, okay. So you form this. This is actually called the ethanol because the 2 carbon, ethane origin, and the functional group is OH. Here is the functional group is OH, alcohol. So ethanol. But the same molecular formula, you can different structure is there. The same molecular formula, the different structure. That is the beauty of the organic chemistry. That is the beauty of the isomer. This is for that reason huge amount, millions amounts of organic compound is formed. Here, suppose this is CH3, OCH3. That means actually this O. Okay, carbon 4 hand, 1, 2, 3, 4 hand. Carbon this is 1, 2, 3, 4 hand. Oxygen 2 hand. Okay. So now this is H, this is H, this is H. So this is CH3, this is O, and this is CH3. That means actually these are. So CH3, this is the methane group, methyl group. So dimethyl ether. 2 separate compound is formed. One is same molecular formula. This is alcohol, this is ether. This is the very beauty. Okay. So this is the very much, you just understand properly in this way. Organic chemistry, the isomer, huge amount of isomer is formed. The same molecular formula, the 2 different compound. Here is alcohol form, here is ether form, dimethyl ether, because the methane group is there. Okay, so this is the functional isomerism. The different same molecular formula but different functional group. Now other is very important. This is called the metamerism. Metamerism actually the unequal distribution of the alkyl group. You know the alkyl group is CH3, C2H5, C3H7. That is the alkyl group, but the different arrangement in the carbon compound or the chain. Suppose here is the C4H10O. C4, this is the 1, this is 4, hydrogen is 10 and O. This is, but if you just write in this way, suppose this CH3 O C3H7 carbon CH3. So what is this? Actually this methoxypropane oxy group. This is the ether group. Methoxy means this is the methyl group, this is the propane group. So methoxypropane, this right is a methoxypropane. But the same thing, this is the alkyl group, but the different right. Suppose this is C2H5, this is also C2H5. The total number of carbon, this is 3, this is 1, 4, C4. Total number of hydrogen 7 and 3, 10. C4H10. Where is this? C4H10. But here is carbon is 4, C4H10. But the different structure, different arrangement. Here is the alkyl group is CH3, here is propyl, here is ethyl. So this is the way, the different unequal distribution of the alkyl group. This is the CH3, this is the C3H7, this is C2H5. Total molecular number, the molecular formula is same. Molecular formula is C4H10, but the different their alkyl group. So here is the form is methoxypropane, but here is ethoxyethane, the ethyl group ethoxyethane, or you write diethyl ether. Diethyl means two ethyl group, diethyl ether. That is actually the metamerism. This form is called the metamerism. So this is for today's complete for the isomer up to the class 10. These are so many isomers in there in the 11, 12 class and on NEET syllabus. The geometrical isomer is the difficult thing. The geometrical isomer, other type of isomer. This is not included in the I.C.S.E. syllabus, but this is syllabus. It only not only also syllabus, but you know better for your understanding. Now one thing is that the number of isomer increase. Very important thing. The number of isomer increase, the number of carbon atom. If the carbon atom is 2, carbon atom is 4, then in case of the carbon atom is 4, the isomer is increased. Okay, suppose butane, 4 carbon, you know, C4H10. Here is only the 2 isomer. But in case of hexane, 6 carbon is there. Hexane, here is 5 isomer. If the carbon number is increased, number of isomer also increase. The combination, different combination, okay. Here, these are for better thing. If there is a C21H44, the organic compound C21H44, in this type of organic compound, millions of isomer is formed. So for that reason, I always say the huge 4 or 5 compound elements are there. A huge amount of millions of organic compound is formed in that way. It's not found in the inorganic chemistry or inorganic compound because there is no scope for the isomer. The catenation property of the carbon, the double bond, single bond is the different types of the. For that reason, the million of organic compound formed due to the isomer. Okay, so this is for complete. Now today I discuss 2 or 3 things. The naming, the what suppose one naming is there. In case of the IPC naming, suppose just draw a structure. I mean, it's clear to this clear to just very important thing. The structure drawing. The given organic compound is there. You just draw a structure on the basis of the IPC naming. Okay, draw. Suppose draw the structure. This is for the exam. Okay, draw structure. What is the question? Prop 1 in. Suppose prop. P-R-O-P. Prop 1 in. In which you draw a structure? This is the question. Prop 1 in. You know the roots. You know suffix, prefix. Okay, all these things. And you know the rule of the IPC naming. Okay. Draw structure. Suppose this is in your question paper is also there. Draw the structure of prop 1 in which you solve. Very easy. You just understand. Prop in. N in I. In means indicate that in the chain the double bond is there and the double bond is 1 position. Prop means 3. Okay. So first you draw. Okay. Prop in which you draw. Don't to be panic. Just to step by step increase. Prop main root. What root? Prop means 3 carbons. Okay. Clear? Number 1 position is in. There is the double bond. Okay. Now 4 hand is complete. Here is carbon 2 hand. Here is 2 hand. Here is 2. Here is 1. 1 hand. Here is 1. This. So what is now this? This is CH2 double bond CH CH3. This is the condensed structure and this is the main structure. If you just complete here, this is H. This is H. This is H. This is H. H. This condensed CH3. This is CH double bond CH2. Is clear? So in this way you draw the structure. Don't be panic. See this. Just you remember all these things. Sequence very scientific. Student very scientific. This one is very scientific. Just you properly understand. Prop 1 in. First you identify in propane. In means a double bond. That means in the chain there is a double bond is there. And what is the position of the double bond? The number 1 position. Okay. And now what is the propane? Propane means 3 carbons is there. So 1, 2, 3 carbon is there. Okay. Number 1 position is the double bond. If double bond is there, is complete. Now you just complete the hydrogen, because you always check the carbon is the 4 hands. Okay. 1, 2, 4. 1, 2 and 2, 4. Here is carbon 2 and 3, 4. Here is carbon 1, 2, 3, 4. So this is the condensed formula. CH2 double bond CH, CH3, and this is the structure formula. It's clear to you? Now the other one. Example. Suppose, very interesting. Just in which way you draw the structure on the basis of the I.P.S.E. Okay. 2,3-dimethyl butane. 2,3-dimethyl butane. Butane, not butene. The pronunciation is very important. Butane means there is no double bond or triple bond. This is only the single bond. It's clear to you? 2, 3. দুটো জায়গায় মিথাইল গ্রুপ আছে, 2 পজিশন 3 পজিশন। ফার্স্ট ইউ draw the word group butane 1 2 3 4. It's clear? Butane 2 3 position the methyl group. This is, suppose this is the 1, this is 2, this is 3, this is 4. If you just write it, this is 1 2 3 4. Now this is, and this is methyl group. Okay, 2 position 2 3 দুটো আছে ডাই methyl group CH3 butane. You just complete the structure. So this is carbon 1 hand, 2 hand, 3, 4 hand. Carbon 1 hand, 2 hand, 3 and here is 4 hand. Carbon 1 hand, 2 hand, 3 and here is 4 hand. Carbon 1 hand, 2 hand, 3 and 4. Suppose this is, so this is CH3. This is CH bracket CH3 because this is the branch. This is CH bracket CH3 and this is CH3. This is the condensed structure. This is the condensed structure. CH3, CH, this is the bracket, this is the CH, this actually called the condensed structure, and this is the original structure. It's clear to you? So this is called 2,3, do number position 2,3 dimethyl butane. This is the word root factor. In which way, just I repeatedly say, in which way you draw the structure. That is very complicated in the student. I just see. Okay, so just a easier way, you just complete this way. Now the next one. Okay, so this is for on the basis of the I.P.S.E. name. Okay, now suppose prop 1 ion, prop 1 ion. The pronunciation is very ion. There is a double bond, triple bond is there. Ion. এইখানটা তোমাকে ফার্স্ট ডিটেক্ট করতে হবে। ion and the number of position is 1. Prop means 3. Prop means 3. So carbon is 3 position. 3 carbon. Prop. And the ion, the triple bond is there. Where is the position of this triple bond? First one. 1 2 3. Is complete? Clear? Carbon 3 hand, 1 hand is here. Carbon 3 hand, 1 hand is there. So there is no hydrogen. Here is carbon 1 hand, 1 2 3. This is the structure. This is hydrogen. This is hydrogen. This is hydrogen. This is hydrogen. Is okay. Prop means 3 carbons, ion triple bond and 1 position. So carbon, you just regularly check 3 1 4. Here is carbon 3 1 4. Here is carbon 1 2 3 4. What is the condensed structure? This is CH triple bond C CH3. Is okay to you? This is the condensed form. This is the structure. Okay, so from here you draw the structure. You draw the structure. Is clear to you? In which way? Just I repeat. Prop 1 ion. First ion. Ion means the triple bond is there. What is the position of the triple bond? 1. Prop means what root is 3. So 3 carbon means is the 3 carbon. Number 1 position is the triple bond. Now you complete the 4 hand in the carbon. The hydrogen is there. And this is actually the double bond and triple bond, the lower position. Is okay to you? Now, other thing is just the reverse of this. If there is a structure is given, if you draw it. What is the naming of this? The structure is given. The structure is given. You just name it. The structure is, this is the reverse just of this question. Structure is, this is the C, CH3. This is CH3. This is CH3. Okay. This is CH2. 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 And this is CH2. Is okay to you? Carbon 4 hand is complete, always check. Carbon 1, 2, 3, 4 hand. Here is the carbon 1 hand, 2 hand, and in this carbon 1 hand. This carbon 1 hand here, 2 hand, and this carbon this. Now you just fully understand. Here is the functional group CHO. So this is the rule. Functional group is the lower position always. If there is a double bond or triple bond, then the priority is the double bond and triple bond is the lower. In case of the functional group, the acid is the very lower. Acid, aldehyde, alcohol. Okay. If there is an acid, the acid is the lower group. Now we starting numbering starting 1, 2, 3, 4, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Is okay? Numbering because CH is the lower condition. First priority is this. CHO is the lower condition. Now what is the position? 1, 2, 3, 4, 5. This is 5. So 5, 5 dimethyl. Methyl. Like 1, 2, 3, 4, 5. 5 position. 5 position. Okay. 1, 2, 3, 4, 5, 5. 5, 5 dimethyl. Dimethyl hexane. What is the total root? 1 root is 6. 1, 2, 3, 4, 5, 6. Hexane. Hexa. This is the nal because this is the aldehyde. The naming is hexanal. Hexanal, the aldehyde nal. You just remember in case of the alcohol OH all. In case of acid, noic acid, this thing. Okay, clear? So first what is the starting here? 1, 2, 3, 4, 5, 6. This is the lower. Starting is there. No confusion. If the functional group is here, you starting from here. Because this is the priority. 1, 2, 3, 4, 5, 6. The 5, 5 dimethyl, 2 methyl, and 1, 2, 3, 4, 5, 6 hexane, CHO, hexanal. Is clear to you? Now the other is there. This for the last today. Okay. This is for last today. Clear to you? Very quick. Okay. This is CH3, CH3, CH, here is CH3, here is CH3, CH2, 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 now CWH. So CW. This is the functional group, acid. So starting from here, no problem at all. So 1, 2, 3, 4, 5. Is okay to you? Is clear to you? Is clear to you? 1, 2, 3, 4, 5. No confusion. The starting from here because the functional group. So 1, 2, 3, 4, 5. What is the position? Alkyl group 4. So 4 methyl, 4 methyl, 1, 2, 3, 4, 5. Pent because the pentane. These are 5 pentane. So pentanoic acid. Pent. PNT. Pent 1. Pent 1 oic acid. At number position. First position is the acid group. So 1, 2, 3, 4, 5 is okay. One position. First position is the acid. So it is the 4. So 4 methyl. 1, 2, 3, 4, 5. Pent 1 noic acid. 1 oic acid. 1 oic acid. Oic acid. The naming is one position. 1 oic acid. Is clear to you? So this for today. If you just understand, please share and subscribe the channel. Thank you. Thank you, student. Thank you for watching this video. Thank you. Okay. Thank you.